Before you actually start using encryption, we got to cover what is encryption. Well, encryption is a cryptographic process that transforms readable data, your plain text, into unreadable formats, such as ciphertext, using mathematical algorithms and encryption keys. This process ensures that only authorized parties with the appropriate decryption key can access the original information. Encryption serves as a fundamental mechanism for safeguarding data, confidentiality, integrity, and authenticity, particularly during storage and transmission across potential insecure networks. Ancient in origin, cryptography and data security can be traced as far back as ancient Egypt, where the earliest known use of cryptography is found in non-standard hieroglyphs carved into the wall of a tomb from the Old Kingdom of Egypt in Mesopotamia. A clay tablet from this era contains an encrypted recipe for pottery glaze, indicating that cryptography was even used to protect trade secrets. In Sparta, there was a device called the scytale, where a cylinder around which a strip of parchment was wound to encode the messages. And then for espionage purposes in ancient India, there was a treatise on safe statecraft which referenced the use of secret writing. The Middle Ages were filled with innovations, even in cryptoanalysis, where an Arab mathematician Al-Kindi developed frequency analysis, which was a method to break monoalphabetic ciphers, marking a significant advancement in cryptoanalysis. Even Giovanni Soro, who is considered one of the fathers of modern cryptography, he was a Venetian cryptoanalyst who led efforts to decipher encrypted messages during the Renaissance era. The 20th century, an amazing time. We have the Enigma machine, which was used by the Nazis during World War II. The Enigma machine codes were famously broken by Allied cryptoanalysts, including Alan Turing, significantly aiding the war effort. We have the Colossus computer developed by British codebreakers. Colossus was the world's first programmable digital electronic computer designed to break the Lorenz cipher, which was used by the German military. We have another father of modern cryptography, Claude Shannon, whose work laid the theoretical foundations for information security. In 1977, we have DES, which was adopted by the US government. It was one of the first widely used encryption algorithms for securing digital data. AES in 2001 replaced DES and became the new standard for encrypting electronic data, offering improved security and efficiency. Now that we got the history out of the way, what is data security? Well, data security encompasses the strategies, policies, and technologies implemented to protect digital information from unauthorized access, corruption, or theft throughout its life cycle. This includes measures such as encryption, access controls, authentication protocols, and regular audits to ensure data confidentiality, integrity, and availability. There are many different types of encryption or encryption tools available to the Windows operating system, starting with BitLocker or BitLocker Drive encryption. We have device encryption, an encrypting file system or EFS, and data protection API. All these features come built into Windows and allow you to do everything from full disk encryption to file based encryption, including leveraging the TPM or TPM2 module, which is the trusted platform module on your system. If you're sporting a Linux system or a Linux distribution such as Ubuntu or CentOS, you can leverage LUKS, which is Linux Unified Key Setup, GNUPG or GPG, which is an implementation of the OpenPGP standard, EncryptFS, which is a stacked cryptographic file system, ENCFS, and Veracrypt, as well as many other standards, since Linux is a vast environment. Rock and Mac OS allows you to use File Vault 2, which is Apple's full disk encryption, APFS, or the Apple File System encryption, and disk utility. Yes, even your mobile devices support full disk encryption and file-based encryption, and you can use these tools on Android and iOS. We have a couple states for data, specifically encryption. Data at rest, which is information stored on a physical or virtual media, such as a hard drive or solid state drive, even cloud storage. Your data in transit being information that is actively moving from one location to another, and you can use protocols such as TLS, SSL, even your SSH for secured shells. Data in use, that's what's in the memory. That's what you're currently actively processing. And it's normally stored in the system's memory or RAM. So for our Windows demonstration, we're going to be using Windows 11. And on Windows 11, we're going to demonstrate the use of EFS, encrypted file system, the use of BitLocker. So we're going to create a volume and encrypt that volume using BitLocker. And then we're going to create another volume and we're going to encrypt it using Veracrypt, which is a free and open source encryption tool. For Ubuntu, we're going to actually create a virtual disk image using DD. And we're going to encrypt that volume with Lux, and we're going to mount it, access it, and write some files to it. Very similar to what we did with Ubuntu. We're going to do that with CentOS just to demonstrate that it's not agnostic to one platform. You can use it on pretty much any Linux platform. Now, last but not least, on our Windows Server 2022, we're going to encrypt a table and we're going to encrypt the entire database, just demonstrating two ways you can leverage encryption in SQL Server.